here from Group 4. We'll we will present it about coal conversion technology, and we choose underground coal gasification for this discussion. This is Group 4 member, and then the first I will give you introduction about what is underground coal gasification. Underground coal gasification, or UCG, is a process of gasification of coal in situ. Coal is converted into an underground gas formed by injecting a high pressure oxygen, steam or oxygen, into the coal seam in a pipe called an injection pipe. And then UCG can be used for an economic coal utilization with open cut mining or underground mining method, or coal which cannot be accessed due to depth, geology, and safety consideration.
The underground coal gasification product. Okay, the underground coal gasification produces the main product in the form of gas, which is often called synthesis gas or syngas. The main gas produced from the gasification process consisting of hydrogen, carbon monoxide, carbon dioxide, and nitrogen, small particle of charcoal, tar, and oil. So, and there is another product from that UCG can be produced. This is the electricity, ammonia, methanol, CO2 compressed. Okay, next. Okay, in this flow diagram, you will see this is the UCG production with the CO2 capture. The first is the underground coal gasifier. In this process is produced the raw syngas. After that, the raw syngas have the clean up the raw syngas to be clean, and after cleaning up the syngas go to water gasification process. In this process, this is the reaction of the carbon monoxide and water vapor to form the carbon dioxide and hydrogen. So after this water gasification process, it's go to the acid gas removal. This is acid gas removal by Selexol. Selexol is the brand of the acid gas removal. So after this acid gas has been removed, and then the syngas is go to the gas turbine. Here is the red one, gas turbine. In gas turbine, it goes to move the generator, to drive the generator, to produce the AC power. In here, AC power is mean the electricity. So in this, the exhaust gases from the gas turbine is go to the heat exchanger, and in this heat exchanger is the steam is go to steam turbine, and then produce the AC power and or electricity again. And this is the with the CO2 capture. CO2 capture is in this process by after the Selexol acid removal. The CO2 capture is compressed in here. In this process is compressed and go to the CO2 storage. Okay, next. This is the UCG methanol production. In this flow diagram, is this the same flow diagram like before, but after the selected acid removal process, they have the methanol production. This is the methanol reaction to produce the methanol, and after methanol has been produced here, and like the same before is to go to gas turbine and get the electricity to heat exchanger and get the electricity again. It's same, but after the selected acid removal, they have the methanol production or methanol reactor here. And next, this is the UCG ammonia production. This is the flow diagram same with the methanol, but you can change the reactor with the ammonia reactor to produce the ammonia here after the selected acid removal process. So you can produce the ammonia to here, and like the same before, this is the gas turbine, heat exchanger, and after before I has been explained about that. So they have any process that I not explain, but this is the main process is here. So I just explain the main process.
Underground coal gasification opportunities. The first, utilizing the deep coal reserve, which reducing uneconomically using conventional technique. And number two, requiring less stringent feed water quality requirement, permitting consideration and directional drilling technology. And then number three, reducing the overall capital cost and operational cost, like a cost for sulfur and heavy metal removal, and reducing the health and safety problem associated with conventional coal processing technique, and the socio-economic impact as well. Number four is providing high thermal efficiencies, more economic synthetic gas, and less intensive fuel gas treatment. And then the last, eliminating the surface coal mining technology, surface gasification plant as disposal or storage, and its related problems.
In this session, we will talking about the challenge for underground coal gasification or UCG process. So as you can see, this is the top 4 challenge for the UCG process. There are carbon dioxide emission, groundwater contamination, technical challenge, and the last is volatilization of mercury, arsenic, and selenium. For the first one is carbon dioxide emission. In the process of UCG, carbon dioxide is produced in significant amount and it should be removed before it released to the atmosphere or utilized for various applications. Second is groundwater contamination. It is caused by the diffusion and penetration of contaminants that generated by the process. In this process, the contaminants is including the PAH, heterocyclic, phenol, benzene, and also cations and anions. The third is technical challenge. As you can see here, we can divide it again into 4 points. The first point is the technology can only be applied to certain site. The potential of UCG site can be estimated by identifying the coal seam structure such as depth, thickness, the quantity and quality of seams available. The second is the importance of hydrogeology of the coal seam. Since the lot of water in the process could lead into the uneconomic process, and the leakage of gas into the underground water supplies could represent the environmental hazard. And the third is oxygen versus air gasification. Both oxygen and air gasification had been tried before. With air, a very low BTU gas is produced, and with oxygen, the process will be a little bit hella expensive. The 4 point is wide-range technical application, technical discipline. The successful of UCG application need integration of such special skills such as chemistry, chemical engineering, geotechnical, geohydrology, and geotechnical. The last is volatilization of mercury, arsenic, and selenium. The fuel gas produced in the process of UCG is mixed with the trace elements such as mercury, arsenic, and selenium. Those trace elements should be removed because when it is used in the such as gas turbine power generation, it will cause deposition and corrosion.
Underground coal gasification method or UCG method. The method is in situ. In situ is have a 6 stage. Stage 1 is looking potential coal. Stage 2 is drilling soil. Stage 3 is underground UCG path. Stage 4 is injection air, oxygen, and steam. Number 5 is burning a coal, and the last is we have a gas synthetic. Process underground coal gasification method in situ. From injection well used to supply oxygen, air and oxygen, and steam used to inject and trigger a underground gasification process. This is a UCG gasifier, and then two product wells used to bring gas product to the surface, and after product at surface we can extract the gas synthetic, and then we have some video about UCG process.